and welcome. It's the 11th of August 2014. Over the last series of videos, I would have liked to have thought you'd reached a certain Dan level of Sunspot Kung Fu, and in the next series of these videos I'm going to teach you to the level of a certain Dan of Photospheric Jiu-Jitsu. What do I mean by that? Well, we have been looking at the Livingston and Penn report on sunspots diminishing after 2015 with a reduction of magnetic gauze caused by an increase in surface temperature heating. And if you look at the bottom of the graph there, it says below field strengths of 1500 gauze as measured with the FE11564 8.8mm or nanometer line, no photospheric darkening is observed. So it's a good opportunity now to explain the link between ice ages and how they occur on Earth with regards to what is taking place actually in the photosphere on the Sun, because that is the area where things change, and when things change in that area of the Sun, it affects the amount of radiation that comes out. So we're going to look at that, and we're going to look at a few details. I'm going to keep it as lame as possible for you so that you get a grip of what I'm talking about, but what we're going to discuss in this video is what actually causes the Maunder minimum to take effect. Now, I've got to say this from the start. Sunspots and the reduction of them was noted back in the 1650s to go alongside with at the Little Ice Age or the Maunder minimum. But what was it that affected the Sun that reduced its output in heat that caused an ice age on Earth? That is the photospheric jiu-jitsu we're going to be talking about, so to speak. So with that, I'm going to get on with the I've got a little diagram that I want to pull up here for you so that you can see what we're talking about. So the photosphere then is this area here. Let me just see if I can get a better marker than this. Right, so this is your photosphere here. At the bottom of this photosphere, the temperatures range from about 10,000 Kelvin, and at the top of the photosphere they range from around about 4,100 Kelvin. So at the bottom it's much hotter than at the top, and that is important because it is in this porous border that, as we can see, the visible infrared radiation and ultraviolet radiation leaves the Sun. And the reason for that is because at the bottom of the photosphere there is a lot of recoupling with the hydrogen ion, and when it recouples with the escaping radiation, it traps it below there. So anything from that point below and that temperature will not escape. As you go up through the layer, which is about 250 miles deep in the photosphere, it starts to cool off, and therefore the hydrogen ion recoupling is less likely to capture that that infrared radiation and the visible radiation. So it's got to be strong in order for it to capture those frequencies of radiation, and as we go up through the photosphere it reduces. Now the thing is, as Livingston and Penn noted in their report, the surface temperature was increasing. So I would suggest, now the reason why I say suggest is because it would be argumentative. It could cause all sorts of arguments with other solar physicists, but I think some of them would agree with me here that this is the critical point at which we get changes on with regards to the photosphere. It's where everything happens, and it's through the coupling at the lower altitudes of the photosphere that stop infrared radiation getting out. So what I'm trying to say to you guys is, if the photosphere is increasing in heat, and that is also called, if we go back to the Livingston and Penn, the limb, there we can see no photospheric darkening is observed beyond that point in time, 2015. So the photospheric darkening, or the limb darkening, is just the same as saying that this area is shrinking, and therefore, you know, that hydrogen ion coupling is taking place more often because it is shrinking, and therefore less heat or radiation is escaping from the sun, and less radiation absorbed by the earth means that it cools. In a nutshell, there is the level of Dan of photospheric jiu-jitsu that I'm talking about, that you need to know. You see, we've been talking about the visible and noticeable signs such as sunspots, which we correlated between, as Livingston and Penn put out in that report very well. They noted that an increase in heat reduced the magnetic ability for sunspots to form, and less coronal mass ejections would also contribute, because as we can see on the diagram, you know, it pushes the photosphere out, and at some point in the photosphere there's a cool area where the the radiation can come out. So I know we could talk about a lot of things there. We could talk about the effects with sunspots and the coronal mass ejections inflating the heliosphere that our solar system enjoys. We could also talk about the fact that, you know, when we have a nice healthy inflated heliosphere, we block out a lot of the cosmic rays that are inbound from the rest of our galaxy. And that's the link then between what causes ice ages. Really, it's the reduction in the amount of radiation that comes off the sun's surface, and it's the important part of this is the photosphere. So, you know, if the sun continues then, in a nutshell, to heat up as it is, we're going to have less radiation escaping from the sun and less radiation bathing the earth. So I want to just draw on another then theory of what we could possibly now be seen as a relationship as we get closer to 2015 and less radiation coming off the sun and less sunspots forming. Now, it is a big inertia, so don't just expect one morning for us to wake up and see no sunspots from that point on. I'm not saying that that could be the case, because it could quite easily be. I mean, we seen last month, certainly the beginning part of the month, very, very few sunspots, and if we look over the months already in this year at the amount of sunspots that have formed, we can see that last month was a significant moment where we saw a reduction in sunspot numbers. So I would say at the same point in time, we probably would have had less radiation emitting from the sun. So let's look at the theory then that I'm talking about, and let's consider then, if the photosphere is the main contributor to radiation being emitted from the sun, then what about high up in our atmosphere? What could be taking place? Let's have a look. So here we are on the National Weather Service, and what we're looking at is the air at the surface, and we're looking at the wind, and we'll have a look at temperature later on and residual humidity. So what I want to do is, because we're at the surface, I want to see what's happening high up in our atmosphere. So I'm going to take you, to 850 HPA, and what we're going to see on the globe behind, I'll just shut it down, is an increase. Well, you're going to see an increase in activity as we start to go up further, higher off the surface and more close to the atmosphere. So at 700 we'll start to see a little bit more. We can definitely see more around the Antarctic region. At 500 HPA we'll starting to see again a lot more wind turbulence at these altitudes, and at 250 again it's increasing as we go up. But the reason why I'm doing this is because I want to show you something. When we get to 10 HPA, this is right up in the atmosphere now, we're looking at wind only. We're going to look at temperatures after that, and we'll have a look at the residual humidity. But something quite noticeable, I think you'll agree, is what we're visually seeing is strong movement around the equatorial region, very strong movement around the Antarctic region. Just want to bring it up so that you get the idea. There you go, there's the Antarctic region, there's your equatorial region, and here's what I want to point out where I think is the first signs of climate change, and it's taking place right high in our atmosphere, and you can see this pretty much the stalling of anything or any activity. Now I'll just take us over to temperatures to see whether there is a noticeable difference there. Right, so we can see again very cold temperatures over the Arctic region, and as I'd expect to see, very dark and cold regions around the Earth, as we can see here, minus 82 degrees. If we go to an equatorial region, just take a temperature reading there. Remember, we're well high in the atmosphere, so don't be alarmed at seeing minus 49 degrees Celsius over Africa. But when we compare it to the Arctic region, we can see it's minus 35. There's a big difference between the Arctic region and the Antarctic region at this altitude. Now I just want to go over to the residual humidity, and we can see that it is noticeable again. We can see more residual. Let's just take a few readings there. So 165 kilometers per hour. That's got to be something. But the point is there's a noticeable change over the northern hemisphere with all those compared to what is going on anywhere else on the Earth. If we look on the Antarctic region, we can see there's a lot more stronger activity down there. So, what my theory is here is what is taking place on the photosphere of the Sun in its higher altitude, with the reduction of the photosphere, and there is more recoupling of the hydrogen atoms, snatching those particles that are trying to leave, those radiation particles and the visible light particles. There's more happening, and we could say that it was almost shrinking. That's what I think's happening. The photosphere on the Sun's shrinking, and therefore less radiation's escaping. I think what's happening is a similar thing on Earth because of the amount of radiation that we're not usually accustomed to receiving is having a direct effect on an area of the Earth over the Arctic region, and that's what we can see high up in the altitude, like it was 250 miles in the photosphere. So now what I'm saying is, if the amount of radiation is affected at that altitude on the Sun in the photosphere, then it's got to have an effect on that altitude or that region on the Earth. And I think this is what we're witnessing here when we look at this, the first signs of possibly an ice age occurring. Now it could also be because we have noted the magnetic field or one of the dipoles over the Arctic region as split. So I would have thought the magnetic ability of whatever holds the climate over the Arctic region to be affected by probably a factor of 4. And the reason why I say that is if you're getting a magnetic pole or a dipole split, then it's probably forming because we don't get monopoles exist, and as it hasn't completely split at the moment. What I think might be happening here is it's weakened by a factor of 4 already. The reason why I say that is, yes, we've got 2 north poles at the moment, but they'll also be forming their antipole because monopoles don't exist. And if that is the case, then the power of the pole, the one pole, is had to be divided by 4. So you've got a north and a south, but a very weak south pole forming over the northern area, and on the other side you've got the same. So you've got 4 poles. 2 are very weak, but nevertheless it's having to share out its power over the pole. And I think that just about does it, guys. I think that there is noticeable changes taking place on the Earth. It's already been reported that there are noticeable changes taking place on the Sun. It's less than 12 months. It's probably less than 6 months away from a point in time where we will see the physical effects of this. And if the photosphere is warming up on the Sun, then we can expect less radiation to be emitted from it, as well as less sunspots to form, because as a direct relationship to sunspots forming, if you increase the heat they reduce in numbers. We've seen that on the chart, and I think it's well worth one last look at the sunspot observations over the last 400 years and that last 3 solar cycles. So we'll do that before we wrap the video up. So here we are, guys. You can see over the last 3 solar cycles there's been a rapid diminish of sunspots, but that is the visible aspect of what is taking place. It isn't the sunspots reducing on their own. That is just an indication that the photosphere is altering in temperature. What it is that causes the ice age to actually take place is the amount of radiation that can escape the photosphere. And if it's hotter, the photosphere, then there's more hydrogen ion recoupling with that escaping radiation, and therefore it doesn't leave. Not even visible light leaves during that period. And if that starts to shut down, that porous border, the photosphere, if it starts to shut down, then less radiation escapes. If the Earth receives less radiation, then it is inevitable that it will cool. And like I say, Livingston and Penn points that very clearly out, and they also give an indication as to what is causing it, i.e. an increase in surface temperature. It has got to affect the temperature within the photosphere itself, and if it does that, it is going to affect the amount of radiation being emitted by our Sun, and therefore will result in a cooling of the Earth. Whether this is going to result in a prolonged ice age or a short one, as was experienced back in the Maunder minimum period, is anyone's guess. But what I want to point out to you is that black line that is diagonally dipping ever more closer to the red line, and within the short space of time we have left, because this graph I believe only goes up to 2013, so there's been another nearly year and a half's declining on there, and we have not seen a change in its course. So it is going, in my view, to definitely hit 0. At that point we know the photosphere will have reduced the production of emitted radiation, and that will lead to a global cooling. This is very important stuff, guys, because you're getting a heads up as to what to expect. We're talking crop failure on a grand scale. We could be talking about the grid failing because of ice building up on the power lines over these northern hemispherical continents, and that all spells big problems for ourselves. And this is what I was trying to say to those people that perhaps have property, that maybe now's a good time to get out of that property, And it's a good time now to start thinking about where to position yourself during such climate changes that are inevitably going to take place on this earth. If you do not see that trend before you on that graph spelling out this, then I can't help you any more than what I'm trying to here. I'm trying to give you a heads up as to what is going to happen, and it is definitely going to happen, and it's going to happen at a time which is very critical for humanity. And what am I talking about? Well, we know there is a resource grab taking place on this planet. They will already have this information to hand, and they will also have probably come up with some contingency plans to deal with this situation when it arises, and it's going to arise, guys. You are not going to avoid this. At the current rate that this trend, or that black line, is setting. The last time this happened was during the 1960s and sorry, not the 1960s, the 1650s, during the Maunder Minimum, and there was very little technological advancement at that age. It will affect us much more. The cities wasn't as densely populated as they are today. It is going to, those cities are false inhabitants only, and the reason why I say that is because the amount of stuff that has to be imported into a city to make it a livable environment could be affected in the coming years. If the grid goes down, if there's if there isn't so much crude oil being pumped out, these times, these winter times and prolonged winter times, you use more fuel over the northern, especially as you creep up the latitudes. England is one of those that experiences on usual time scales relatively mild winters, but that could change. And I told you that what could possibly be a scenario is that, as we have seen since 2007, especially that one year a couple of years ago, where we had most of Europe covered in ice, I was surprised that that reflective surface was able to be melted, because what little radiation will be coming off the sun could be reflected quite easily off of very brilliant surface such as a snowed out northern hemisphere. And I said this, you could go through one winter where it doesn't thaw, and I think we was very close the year before last. So that's all it takes, really. And once you start getting a more reflective surface and a more the more humidity building up in the atmosphere, which has been happening, that's why we've been getting all these flash floods, drop the amount of precipitation in short spaces of time. It's all linked, is what I'm saying. But my concern is, and I suppose the purpose of this channel is to make you aware of that. And all I can say is you could take this to the bank that it is going to peter out at zero, without a doubt. There's been a lot of scientific information provided in these series of videos, and I don't see anyone else explaining to the depths which I've tried to do in a layman's terms, so that the majority of people can understand what is actually taking place. What I'm saying to you guys is it is going to take place, and as Livingston and Penn put out in that graph, it's going to take place during or around about 2015. And you need to think about that and give that some serious thought, because your property isn't going to be worth nothing if it's in a position where it is unsustainable. If you can't get food, you're very likely going to end up migrating to a location that is favourable to sustain life. Could that be what we're seeing now in the Middle East, with the shake-up of a lot of these places that are going to experience a cooler climate themselves, but are going to be in a favourable climate that food production can be used. You remember, if we just go back a few thousand years to the Egyptian periods, where the Nile, either side of the bank of the Nile, was very fresh, fertile lands as opposed to desertous regions now. I've also explained that this could lead to the possible of crustal displacement. You've only got to look around your coastal regions to find limescale cliffs, such as in the UK, the White Cliffs of Dover, and where I was last week, Bream Down. These were areas that at one point was under the sea. They couldn't have formed limescale above the surface of the sea otherwise, so they must at some point have been pushed up. You've only got to look at mountainous regions and ask yourself the question, what force could form mountainous regions? What I'm saying to you is it is not uncommon in the nature of this earth to do such things. And could that be caused through a magnetic reversal and another ice age? Well, they all could be closely related. There's a lot of things that scientists aren't talking about right now that I feel are very important aspects of what is taking place. For instance, they haven't included the magnetic field in their weather modelling systems. Now, that I feel is a big uncertainty in their calculations, because there's no mistaking, or there's no coincidence that we have a rotational axis over the Arctic region and Antarctic region. We have the most coldest regions at that vicinity, and we also have magnetic poles or dipoles over those regions. Now, you don't hear scientists talk about those things. Those, they're not coincidences. They're all part of a system of this earth and the nature in which this earth goes about its business. These are the things that people aren't talking about, and you haven't heard much talk about the photosphere being responsible for directly affecting the climate. And these are mechanisms. If the photosphere is responsible for discharging of radiation, then it is the radiation that heats up the surface of the earth. That's where we get our heat from. If the photosphere is increasing in heat, then it is going to be less favourable for the discharge of that. The gate will close and there will be less radiation escaping, and therefore this earth will shrink. Not shrink. It will go colder because of the lack of radiation that it will receive. Now, it doesn't take a lot. It doesn't take a lot at all. We're on a very fine balancing point here, that if we'd have been probably 1,000 miles closer to the sun, there would be no water on this earth, and if we was 1,000 miles further away, all the water would be frozen. Remember, Mars had a magnetic field, it had an atmosphere, there was water on it, and all three of those are not there now in abundance as there was at some point. So, this just demonstrates, the Goldilocks position of our Earth right now with relation to where the sun is. I didn't expect the research to turn up quite the results that it has. I've got to say that, guys. From a scientist's point of view, I find it very exciting to see such changes taking place. What I do feel a little bit upset about is that there aren't more scientists that are coming out and talking about this, and I feel the reason why they're not is because it's not a clear-cut science. There are still some discrepancies in the data that we collect and how we collect it, and to just make conclusions on the data that we have to hand, they feel a little bit uncomfortable, and the organisations probably that they work for wouldn't want them doing so in any case. But we have had like I say, some scientists from NASA, NOAA, comment on some of the work that we've conducted on this channel. Some of them have said I'm a crackpot. Well, I say, if you can't see what I see here on this grid, then perhaps, I'm not I'm not the crackpot here. I can see a trend over 36 years of sunspots diminishing, and I can see when I look at graphs during the Maunder minimum in the 1650s what that led to. So if you want to call me a crackpot for that, then fine, carry on. I don't care. I'm just showing people facts and letting them decide what they want to do with them. That's what I've done for the last 2 years on this channel, and that's what I'll continue to do. We are going to see this happen, guys, and as long as the internet is available, we'll follow this along. This is the biggest story, and I've said this. How we haven't got more subscribers on this channel is beyond me. I dare say there might be a little bit of influence from GCHQ manipulating things more on this channel than they do on others, but I'm doing my best. And what we really need is the awareness of this to get out, because we make up a grain of sand on the beach with the knowledge that we have to hand, and we shouldn't take that for granted, because this is going to affect 7 billion people on this planet for sure. So if you can do your bit, whether it's make a donation, to contribute some of the time that I invest in doing these videos, or you can share the video with other people, to start discussing this matter with your families. This is what you guys need to do. This is your part. You need to play in this. This is what needs to be done from this point out, because we are so close. We are less than 6 months away from noticeable changes, and it is at that point the panic will set in without a shadow of a doubt. I think I've kept you long enough, guys. I hope I have given you a Dan level in photospheric jiu-jitsu, or a crash course in that, and what is actually responsible for the reduction in climate temperature on this earth. And like I say, just watch this space, because if that trend continues, then you can take this to the bank, that this earth will certainly cool down. Link below, guys, if you want to contribute. As always, get yourselves prepared in some form of manner. You don't want to be the last in the shops, when there's only window wiper blades on the shelves to buy and bottles of bleach. That it doesn't leave you a lot of bartering potential. As always, guys, I'll say bye for now. Be safe.